in the networking space, but I kind of sit on a fence in between networking and DevOps, so to speak. So I'm going to talk a little bit about NetDevOps tonight. Anybody kind of heard that? Cool. How many, well, first off, I got a couple things for you, right? A few slides. I know we all hate slides. I've got 2 demos to make up for the slides. And the demos, I must ask for forgiveness and answer the recording. Because there's nothing worse than standing in front of a group and then have your demo break because your internet connection went down or something like that, right? So I learned that lesson again 2 weeks ago. Anyway, so just a quick rap sheet on me, just my background. I got my Twitter handle up here. I don't frequent Twitter, and I spend a lot more time working than I like Twitter. So I try to spend more time writing playbooks and stuff like that. Got a lot of time in the networking business, about 20+ years. A lot of the big names that are out there, the Junipers, the Cisco's, VMware. So kind of been around the horn a little bit on the networking side. So probably the last 4 years or so, I've spent a lot more time in the software business, trying to kind of bridge that gap. So initially it was SDN and NFV. It was like, okay, working in a telco environment in the service provider space for a while. Those 2 terms kind of caught my attention. The use cases caught my attention. And then I moved over to the data center world and really started working with software tools in a lot different way than what I was used to. So, in the old days, it was expect scripts and, write scripts from a Unix or a Linux workstation to go out and do special things on the network. And so kind of looking at some of the next generation tools, it was a whole different mindset than what I was used to. So I'm kind of here to talk a little bit about what we've done on that front in the last year or so, a couple years. So I want to know, that's all about me, right? So I want to know a little bit more about you. I've been part of this group for probably, this meetup for probably about 6-7 months now. I'm usually on the road, so I catch a lot of the podcasts online since they've been online, and every once in a while I'll pop in for a meeting. But I kind of want to get a poll to see how many network engineers are in the room. Got 1, 2 recovering. So what exactly does that mean? Used to do it.
I'm ready to go on the cloud, so I can network more of that.
There you go. Okay, so just a handful. All right, that's good. How many of you are familiar with white box networking or bright box networking? A few more hands there. Okay, outstanding. And then how many of you actually automate networks? A couple here. All right, very good. All right, so these are all kind of subjects that we're going to dive into, right? I'm not going to get into the bits and bytes of networking like, hey, here's how you turn on OSPF and here's how you make it work. Because most people kind of get that down and don't. So like one of those where for an automated network, it really doesn't matter those details if we've already got it all kind of cleared up. All right, so first things I want to talk about is the white box. What is the white box? How does the white box work? Why is it different? So if you look at the slide here, the traditional networking equipment has typically been, oh nice, some screens pointed at work on too. So traditionally you've got software locked hardware, right? You buy a box, the box, you got a label in the box, you got software come out of the box, you just get rid of software. But you get what you buy. There's no real choice in that, except for what version you get. Any disagreement there? No, okay. So in the computer world, it's a whole different ballgame, right? You buy a box, you plug whatever cables into it you really want to, plug in pretty much any interconnect you want to, and you put whatever operating system you want to. Right? No disagreement so far? So SAN kind of the same as compute to a certain extent. But the point here is the hardware on the networking side is completely different, treated differently, operated differently, the whole 9 yards. So what white box is really driven to do is kind of take that disaggregation. You know what that means? Disaggregation is basically saying, okay, what we've been doing in compute for 15 years, now do that in this place. Pick a piece of hardware, put the software on you want, and use whatever cable you want. Basically, giving you choice. Nobody touched that? Pretty simple concept. I've already seen it once. And maybe the first time around it was a little bit easier. Now it's just, same thing's happening in a different place. All right, so just just real quickly, just kind of a handful of vendors that are actually offering these choices, right? If I look at the hardware choices, these are vendors that traditionally have been vendors for the most part, but also offer networking. Where they sit as far as stack rank in the network space, it's going to vary, right? Depending on what they're doing and what's important to you. And the operating system is just kind of showing some of the more relevant operating system on the server side, on the compute side, and then of course on the hardware side, the network side, it's a different brand than most folks use. So my employers just happens to be on the operating system up in that box in the far right. Top right. All right. So how is this all possible? What was the driving force behind actually making a change to the open networking in general? And then it's really revolved around system on a chip. Does anybody not know what system on a chip is? Basically, it's a reference design. So here's an ASIC that does these functions. It's on a chip, and we reference design around it. From that reference design, build the systems. So if I take and look at different vendors across the top here, and there are different box numbers, they use system on a chip design to build out the boxes in the ways, the components to make up the network. So having a reference design using the same chipset across a whole bunch of different manufacturers, different entities, there might be 3, maybe 4 actual facilities developed that actually produce these boxes. So they churn out boxes, they throw a different logo on it, and before it goes out the door, they might go to the software. But it's like it's brand logos, and that's exactly the same box. So really differentiate that point of things. Not the box, it's the software. Chip's the same, the box is the same, make sure it's different. How you interact with the box. All right, so I did a talk at OpenStack Summit 2 weeks ago, and they recorded the thing. And my wife's like, I want to watch it. I'm like, please don't. And so she hit play. And I'm just kind of listening to her. So we talked about it really that fast. So if I start talking really fast, I'm slowing down for this. So if I start talking too fast, they'll slow me down. All right, so what I'm really working on is, I don't want to check more jokes.
Slow down.
Slow down. How do you inject more jokes into your talks? I was going to work on that. Oh, okay. Cool. Got a little interaction. All right. So this is an absolute pie chart. And I throw that up just to kind of show evolution in networking systems over the last 25 or so years. And just kind of showing from left to right. Now, what's a monolithic OS? You know, that's kind of a marketing term, right? Monolithic, one big blob or something. And you just kind of look at the progression. And one thing that we talk about here is my particular employer is we build an operating system, but we really build it from scratch. It's Linux, and the whole white box story kind of builds up to this Linux enablement and interaction with the product, and which in turn comes right into the DevOps, right? So doing DevOps or NetDevOps with a box of Linux versus Linux-like can be different. All right, so I'm not going to go into much myself. Anyway, so as far as how they're coming together on the white box front, you're going to have, of course, it's kind of like all hardware stuff, right? And like if you go plug a server into a jack, like a 45 jack on switch, what happens? Somebody kind of walk me through what happens in that process. Start talking. Does a DHCP request, gives an address, and then what happens? Does it fix? And so download some software, maybe download a hypervisor automatically, just plug in and magic happens, right? But somebody did something somewhere to make the magic happen. You don't have to go in and actually touch every single server. I used to do it that way, but it's real pain with that, right? a lot of work. Touch every box. Anyway, a little sidebar conversation there, but anyway, the software that's on the top of the boxes that enables that component, right? So how do I go talk to the world? Because the networking products that are out there typically, if they don't have an operating system on it, what's it going to do? It's going to look stupid, right? So none of us like that, especially so this guy's got a thin layer of software that goes out into that registry, pulls down the image, I as an administrator say, there's an image you can download, use this, and then from there, it just put it out in the process to basically configure yourself. And once you configure it, I'm talking to the world, now I interact with you in a way that says, okay, go turn on this routing protocol, or turn on VNX for XYZ application, for micro stack, something like that. So, very high level. Anyway, then the operating system sits on top of that thing that I'm talking about. So once the software is downloaded, in this case, it's an external with the kernel box to the silicon and then user space box to the kernel. So basically, you're still programming silicon like you do with custom devices, custom software, custom hardware. But in this case, this is all extracted from it's kind of it's the same across a whole bunch of different matters. So how you interact with it is all about this understanding. All right. So anyway, what does that look like in the end? The server will look what's in it or not. That's part of the story. Actually, I'll take this back. All right. So open networking. This is so we talk about a little bit from a hardware and software perspective. This is more about open from a tooling perspective. So what happens if it's Linux, you kind of got a whole that software that you use, right? So, all right, we're here to talk about Puppet on bare metal, right? So Puppet it runs as an agent-based automation tool, right? Puppet Chef Mode, Ansible will be more or less agent-based. I don't know what it's on, but you use Puppet in this example because it's a little more of a challenge solver. So in a traditional box, I went to all the boxes. On a server, that's a little operating system, right? How do I do it on a network device? Some cases you can't. Some cases you can't. Some cases you get more flexible to it. But there are ways of getting it done, but if it's Linux, you just install it like you do a server. So like say for instance, some of these Ansible, I can use the same playbook like I use to install the Puppet agent on my servers. I can use the same agent to install the agent on my network. So I can kind of see the parallels and exactly what this kind of holds up. That's just one example. You start looking at apps and monitoring, that seems to go all pretty much all on apps, right? Except for the one log. That's basically the pipeline to do network. It's basically make the networking, make the Linux device look more like a traditional networking device for people that don't know Linux well. All right. Anybody know what an ONI is? Yeah? How about an APD? Can I get somebody to help me out with this, tell me what the ONI is? What does that mean?
I think that's the driver that interacts with the hardware, right? So it's at the hardware layer.
You do a lot of
No, like,
yeah, you know, that's what I've seen the options on with Delta.
Yeah, exactly. Exactly. So,
I'm cheating, by the way.
Are you?
No.
okay.
I'm a different I come down and check that.
Oh, very good. Good to see. All right, so we got a couple guys that know what ONI is. Who knows what APD is? You need to take this back to Michael Bell and say, hey, this is cool, but we can do this too. So ACPI, you guys know what that is? So it's platform description, basically, right? For like you know, platform description, so it tells us the software. It's like the hardware saying, hey, here's what I need to do, here's how you talk to me. So if we can do that on the servers, why can't we do that on the network?
You can't.
Exactly. That's what APD does. So we go out with an APD, get out of our RCC so you can put it out. All right, any questions on any of these? Anybody know what this thing is? So here's what's that? It's a what? Very good. Okay, so then a history lesson. What's a quagga? Outside of the software world. It is? You're right. Just a trivia thing. It's an extinct zebra. A quagga. What's that?
The hot zebra and hot pond.
Yep, there you go.
But
Thank you. Very good.
I don't know if I would call something technology like extinct or a dynamo. Like, that'd probably be something I'd want to stay away from.
Good feedback. So what should I use instead, you think?
I don't know. I mean, is that what it's really called, the router?
Yeah, it's an application. Yeah, it's an app that runs in Linux. So there's another one called Bird. But
No.
Naming things is hard, right?
Yeah. But so Quagga's been around, my goodness, 20 years?
That's what outlived the owl.
All right. So we're getting to the DevOps. So I'm going to run through probably 6 different examples of automation use cases for now. The first one is all, so there's going to be one that's kind of, you don't got to go, no kidding, we've been doing this for years, but it's a little different way to do it. But the first one's rapid provisioning. So obviously, if I can provision servers without ever touching the logging on the console, I can do the same thing with anything else that's out there. It's just a matter of how difficult is it going to be to interact with that device. Do I have to write to the API? Is it the agenda? How do we release? Do I write to a CLI? Do I write to this flat files? Just how do I interact? That's determines how difficult that's going to be. So if you've been doing automation and compute for as many years as we have, why aren't we doing it more in the network? It's because of the difficult about. Everybody's watching the network or typically it says it's a CLI. It's going to so if I automate for one box, and I want to set up a vendor strategy, I got to automate for a second box. Then I got to know which box is which, how to talk to each other independently. And oh, gee, why ever decide to put the third vendor in? Do I do that? Automate third time? So you get that. And one of the ones I kind of like is hotspots full switch. So how many times have you been, well, if you're a network admin, for instance, turn on the network, everything's running great. Magically, the hardware platform just goes to flip. Power supply failed, the electric power's hit, the circuit work. Something happened that box went out. Then you go back and look at your big backups. The next one, and you find out, oh, gee, the configuration backup won't work right last month. What do I do now? I got to go back and try to recreate the configuration from scratch, which I may or may not get right. So depending on who's screwed on Monday morning, you're going to determine how to put it up. I did want to create that configuration, right? So if I automate my configuration backups, this is less of a problem because now I can swap out that whole switch. If I'm actually letting, if I'm actually keeping all my configuration and running, like say for instance, manifests against the new boxes and having a better automated big, I don't necessarily worry about backing up into the file. Every time a box is pulled out, I just rerun the manifest against that box, and it's back on running in no time. So it's just kind of a no-brainer moment when you sit back and look and say, you know what, these all my maintenance windows to better cover from an outage might not be necessary. And then, of course, the configuration management, this is kind of low-hanging fruit, right? But I say that, but I spent 6 hours yesterday writing an Ansible playbook trying to back up directory structures with fetch, which is 1 mile at a time backup. You can't. So anyway, I'm running Vagrant on my machine. And I've got this network simulation for a customer. I'm trying to prove to them what we do. fully upgrade across the entire data center fabric without having any downtime. Basically, and so Vagrant doesn't like parsing. It serves on own commands. Coffee was challenging for various reasons. Infection was for one file at a time, and I was building an entire network with interface.d individual files for every interface. That's the way I decided to build it. So instead of just copying them as an interface file across, I got about 50 files, up to 54, so right, for the previous ones. So anyway, my long story, maybe that's just really, really bad. Point is, that's 6 hours, that's that one exercise, we'll probably save how many hours in a maintenance window or day-to-day operations will work. All right. Application deployment. So I'm going to actually show you guys this, but I think I've already kind of talked about it. I just do an app install Puppet, agent, all part of my automation as far as starting. Maintenance tasks, so automation on the box. Basically, this is all then user admin, this is kind of a regular field. Okay. I'm going to do user admin, robot database system. I'm still doing that. And I want to go clean up users. I don't have to go log into every single box to do that. I can just, play with that's what I do. Bullshit catch analysis. Okay. Anybody know this, guys? I don't have the voice to, what if you could do so much more? I try to get that off the end, come on. Anyway, that was kind of some basic static examples. And then if you can take this further, right? Say, okay, I want to have automated reaction to certain events. So now I'm going to trigger events based on things that happen inside the box or inside the fabric. So in this case, bad fan. I get in there. Maybe it's an SMP trap. Maybe it's something from sensors telling me, hey, you get a bad fan on that box over there. And so now I say, okay, get that fan order. I think this is bad actor on what? So I can say, I can write rules and say, okay, if I see this event, go do this. And in this case, route traffic, all the traffic around these links, around the box, to take the other three boxes, take the traffic. That way, no human intervention at all. And if I don't have human intervention, I only one more possible cause of additional avalanche.
But I've never, like, I just made one of those coming, get the traffic, so it failed midstream, not drawing the traffic.
Exactly. Hitless upgrades, I kind of already talked about that a little bit. So the hitless upgrade piece is basically just that. Okay, steer traffic one way. I've got connected links from every stack. Steer traffic one certain way. Let me upgrade to this other box. And then whenever that box is complete, I can have checks in place to say, hey, go check the health on this guy. When he's back up and running again, revert traffic back to the primary, back to the path, and then we'll go ahead and upgrade the device on the other side of that. The whole EV connection, so the next sort of one, and the mitigate is going to the switch on the top of the switch up here, and then maybe go to the next going to switch over here. That one we count, we'll share that up, and then provide a way to get it. With one bosses. No ISSU, no big chances. Make sense? All right, is there hot here? Or just be all right. Anybody follow that? No. Good. All right. Automated threat response. Basically, you see some kind of something that we're just about area event. Trigger automated response to it. If I see certain traffic patterns push voltage down, security rules down the device, but basically lock out whatever is a threat. In other words, if I'm sitting there, if I'm logging, like, say I'm looking at, say I'm sitting there and looking at traffic, I'm doing an R-scan, or something like that. I say, okay, I'm seeing something's doing the analysis beyond me, right? I'm basically doing my job, I'm sending packets to where we want to send. And then that device says, hey, you got a problem over here, I'm seeing this based on some anomaly or whatever. Push roll down to set the device, and then the enforcement plan down to actually block that traffic.
The reason I asked that, because it's contained in that.
Now, it's Linux OS, but you've got a switch with X amount of CPU, X amount of memory. So you want to have it, but you don't want to get too carried away with how much. If I try to set everything Linux on it, I wouldn't suggest that at all.
Can you go back to the
This guy right here? Actually, this one's going on. I'm actually showing you this. It's for the demo, but I don't have everything written. So it's like I don't have the actual box with the fan failing. I'm simulating that and then trigger my events to go from that. But you actually have a specific social on that?
No, I kind of felt out when you were explaining, so when you
Sure. So let's say that I've got a device that's the fan failure is the example here, but it can be anything. It's power or maybe I'm getting carried. Yeah, but I'll take back. Just take your pick or whatever it is, and I'm sending some kind of a notification to a northbound system. Like say for instance, it's going to. I'm going to do old fashioned and say, oh, that's going to be receiver. I got traffic in there. Traffic to the fan dead. The fan's up. So the fan is slowly to the point where it's dying. It's dying. So I know that device is out of service, or maybe it's even out of service. So I want to proactively reroute traffic off that device. Telling me something's going on. Take that return to the event and then push down action. And say, okay. Make X, Y, Z happen. What you see, my demo is on the next round the whole life. So the other device around it while I keep that device out of service. Makes sense?
Yeah. Once it overheats, it fails, and it fails, it travels.
I keep using this slide here. This is our CPU has this like demo. It's like if you're on live demos, this is so big. It's like it's down the rail, off the rail, right? Anyway, so here's kind of the deal. Right? On the demo, I'm going to take you through the slides. I'm going to show you that. Here's exactly what I'm going to be doing in the demos, and I'm going to actually take you to the demo and actually show the process. Kind of walk through the step-by-step process here. So anyway, the first thing we're going to do is something called zero-touch mitigation. So basically, when a boot speeds up, this is kind of what I'm talking about. It comes up with anything on it, right? So it goes out, pulls it down the software, and then it goes out, after the redoes that, pulls out the software, doesn't put the execute request. It's an option 239, the provision script. The provision script says, hey, go to this server over here. Actually, the DHCP option tells you the provision script. The provision script comes down, and then it does basically, it just runs through an automated process to install whatever I told it to install when it comes online. DHCP configuration. So it's pretty straightforward. Basically, just this isn't unique to a certain vendor. A lot of people do this. Some of them do it a different way. So it's an example of what I've got. Here's the playlist, so I'll focus it. Specific option, you tell it what code needs to be used, and then you get the server URL. So what does this remind you of? It's maybe a little bit.
But you can store Cumulus OS on Flash. You don't have to go through the.
Yeah. And that's probably a lot of the awesome, right? So it's like, yeah, put it on Flash. So I say, all right. So that was the DHCP configuration. This is actually the script. You can see doing apt-get update, apt-get upgrade, apt-get call. And then various configurations actually doing a restart of the property. This all happens on the switch when it boots up. All right. So basically, that was the precursor slides that I warned you about. So the alphabet soup, I don't know what I call it, because it's got OSPF, Buffett, PTM, and ZTP. All right. So we want to go through the alphabet soup, TLA, Susie, OSPF. Anybody not know what that is? Okay, OSPF is a routing protocol. So just if you're doing like the data center fabric, you've got a couple of ways of going about it. There's a layer 2 option where it's facing up different devices, or layer 3 where it's all IP address. And I have IP rights. And OSPF is a dynamic routing protocol. I should have asked you to do this information.
Sure.
Sure, I'm not. Anyway.
You bashed my company too bad.
I didn't bash you at all. This is my buddy John. He works for Sorry, John. All right, so probably we know what that is. PTM is a prescriptive quality manager, and I haven't talked about this at all. But what PTM does, it says, I create a diagram if I want to. It says, here are the boxes I've got in my here's how they're connected. I got what's talking with. And then from that, this diagram basically creates a file, a flat file, pushed out to every device's network, including these few devices I want to. And then from that file, I can actually, when devices come up, they use LLDP, which is another alphabet soup protocol that talks between devices to make sure that they're right up. Who's on the other end? And then they compare the notes on what those devices are with my neighbors to this PTM file to determine whether it's cabled up or not. So you might think, okay, big deal, right? But if you think about turning up racks and racks, rows and rows of servers and switches and switches to switches, the chances of somebody having this cable are actually pretty good. Not only that, finding where this cable can be really hard. And so this is an incredible time saver. All right. And CTP. So CTP is zero touch control. All right. So the demo. You guys ready?
For the train wreck?
Yeah, the train wreck. It shouldn't be too much of a train wreck because it's recorded. All right. Here's play. Oh. Well, let's go quick. All right. I'm going to kind of stop at a few points here.
No, you talk fast, you build fast.
Yeah. All right. So this is what I'm working with. It's something we call a workbench. And it's just like a rack of servers and switches that are just sitting there at my disposal, like tired of the configuration options. So I've got. That's kind of hard to see. Yeah. Okay. Spine 1, spine 2, leaf 1, leaf 2, and the links are hard to see, but basically this is everything is dual connected. You'll see in data center terms, this is what they call a traditional bow tie, where this device has connection to that device, this device, and this device. So basically they crisscross. That way I've always got an open path. And then the servers talk both of the edge devices back. And then I'm going to be doing everything on the CLI, bash console from this workbench device, which is the button server. So when it comes up initially, it comes up pretty base. All right, so that is the Ubuntu server. The W bench, you can see right here, everything's got its name on it, right? So the workbench is the Ubuntu server we'll be working from. And I've got team ups and screen. And so you can see the guy that runs the lab is pretty clever. So you actually put a diagram here so guys like me, when we log in, we think, oh yeah, that's what that guy does. Browser, etc. Anyway, play again. So I just kind of walk you through And I'm going to have to go this open to essentially all of the devices. Spines on the top. Spine 1, spine 2, 1 through 2. Kind of go log in and password. I type really slow. I'm not going to talk. So we'll allow almost that. All right. Log in spine 1. This is kind of fast forward. Whoever edited the video is really bad at translation. It cost me $150 though. I might have to get almost send a penny back to that this year. All right, so I'm going to show you the network, the interfaces file, just to kind of prove out, even if you're really going to loop back in there right now. So Quagga, anybody remember what a Quagga is?
Yeah.
Sorry. All right. So no Quagga configuration here. Same configuration on the interfaces file here. All right. Now, this is a cheater. I love this. All right. Forgive me for my cheating. I'm all about shortcuts. I go to our website, and we have this whole stack of demos, right? And the alphabet soup demo, although it's not named as such here, is something I can go to GitHub and pull down. So if you're going to cheat, why not do it right? So I went and pulled down this OSP at 100. And well, that's the boring node option. So I actually go for the corner option. This guy right here. So same thing you already kind of saw, right? In the diagram. So there's the GitHub link. They go to the GitHub link. Basically, phone the thing in the workbench. And you see it. This thing is, I'm serious. It's a serious cheater. Basically, it's got step-by-step instructions on how to do all of it. I promise the next demo is a little bit more clever. But this is kind of the basics of automation stuff. So that is the workbench again. You can see there's a whole bunch of different image files and all that stuff. Kind of go through here and show you all you got. Remember I told you all you got that all you got dot file. That's the file we put on the top. So I want to make sure that gets pulled down. And I can send you guys for stuff on
Looking to verify that neighbor.
What
information is he looking at?
LDP. So LDP is going to tell you. It's going to tell you your neighbor who's using the.
Okay, so it's not map.
How do you select the values?
Yeah, is it a user interface or what's the?
It's a flat file.
CSV.
No, it's a flat text file.
Interface, talk for this interface or command for that, or?
I'm going to hold on just a second. I'll show you what.
I mean, I understand the LLD verify. You're telling me what it's supposed to look like, right?
This is coming up as a Word doc. Yeah, you're actually going through it. You can either do this from building a drawing and actually say, from GraphViz or something like that. I knew I told you to do it from Visio, but I hadn't tried Visio. So I can do it two ways. I can build a Visio, I can build a GraphViz file and have it kick out this, or I can build this and have it generate a drawing. So I can do it either way. This is actually one of the topology, and you can see it's a spine 1. So this is a graph for data center 1, for instance. Spine 1, switch port 1, like the lead 1, switch port 51. So I basically go through and list everybody out there, and I've actually done this concept where you actually put the servers into it. If you had all of you run the servers, yeah, why not? Exactly. Just run PCM on it.
You can always take the graph if you do an exception because your neighbor isn't who you expect.
So I would go to the I would actually go to the device
and
you can actually do this through automation too. But if I'm doing it manually,
I go to the
I go to the device and I say PTM, CTL, and it spits out the whole list of what's supposed to be connected to me and tells me pass or fail. But if I'm feeling clever and using my automation tooling, I'm having an automation tool go out and pull all that stuff down and basically pile into a list somewhere, and going through and looking for fails. If somebody has a fail somewhere, I trigger an event to say, hey, got a problem over here, go fix this. You sit in Python training all day and come do the automation at night. It's awesome. Good man. All right. So I can't memorize all these instructions. So I just kind of forward. So get out, update. Kind of see it's working through the formats and packages. I'm going to go ahead and pull down the demo here next. This is the bottom part, right? Just watch.
It's the slowest you spoke all night.
I know, right? I need to take that back. Roll the way. So starting Puppet Master, this is actually starting Puppet Master on the workbench device.
So are you advocating to have the Puppet agent running on the switch? Why wouldn't you just interact with it from the workbench? Is the workbench not a permanent thing?
So the workbench here is more or less just a gateway to get into the lab. So the workbench is actually acting as a Puppet. And then the switches are all acting as agents.
Devices.
Now, I guess a crazy idea, you could literally drive a Puppet Master from a switch too.
Yeah, if you really want
You can download the master there and then run from there.
There's you got enough memory in the CPU to do it. That's what
Not easy to expensive, you could have one of those too.
Right. Yeah, we get. It's funny. We had talked to guys who want to run Docker containers on the switch, and it's like, let's talk through their use case. I don't understand how to learn about it. There's you go okay. You get a Linux platform on a switch. You kind of go too far out there sometimes. It's like, remember how much memory you see you store. It's not infinite. All right. We're back up to switches rebooted. See all four of the screens actually. So now I'm taking back to the leaf. Leaf 1, leaf 2 over here. So here's that output, that PTM CTL. Pause it real quick. What's that? Prescriptive topology manager. So I always do the stuff. It's either physical topology manager or the topology manager. I always thought physical. It sticks better. For me. So you can see in this case, it's telling your table status. You can use LDP or you can kind of see over here, use BFD. You only use BFD. So I'll kind of give you control over the timer a little bit better. And by the way, in case you didn't know, not all LLDP is created equal. So in some cases there might be interoperability for them between the server and servers. Anyway. So it's kind of doing this command right here. All I'm showing is there is no OSPF neighborhood. OSPF is a dynamic routing protocol. So the demo is not complete yet, right? So far I've got the agents running. And then you can look with some of my typing. So now the agents are up, basically, but it all just kind of comes off the back. That's how they go out. It's just kind of stagnant. You see that he's basically got a whole bunch of peers. I wasn't trying to get the talk here at all. It's kind of showing. It actually works without having to configure anything. All right? There's a whole 2 minutes left in this stuff. I should probably move this out of the way, so there we go. So we cut the down, we're looking at, and now we're looking at the interfaces. See, files managed by we're not using the interfaces file, we're going to fixing.e directory. So what does that mean? We're going to have a whole list of files. You can see the acquired configuration now. So plug up. It's got all the routing configuration in it. You can see that there wasn't no acquired configuration before. I plugged it up there, the whole built out without having to actually put much better.
This also support L2 environments, so spanning tree, I'm assuming when you're running.
Yeah, you gotta do all that stuff. Doing that away, right?
Yeah.
MLAG is beautiful, but clear through is better. All those deals. And then that's
Okay. The only way I ever learn is by listening.
right.
Okay.
You know, I mean, after a while, what you find is that we're all clueless monkeys just trying to figure out what's going on.
We just need to speak with someone else's language.
That's right.
All right. There's my list of interfaces for that device. And then so I just kind of popped out the shit. One, just kind of show one mile or whatever. Those are what's I'm there for, right? Any questions? How small? You mean as far as space? I'm running the virtual. So let me show you this. I've got my provider running on here. I'm running Vagrant as an orchestrator, and I'm running VirtualBox. I'm a recovering VMware addict, so I'm running VirtualBox because it works so well with Vagrant. Right? But to the question directly, I'm just going to show you. Base memory 256, 8 mega memory. It's not a lot. I mean, I'm giving it 2 gig of disk space, but I don't even need that.
But this
is the virtual machine.
so when I'm doing like chef stuff or whatever, I'm doing a similar, like most all of us have a test, like a kitchen or a test kitchen looks similar.
Exactly.
Maybe a little more research.
And actually, somebody was telling me, I thought the test kitchen was just for chef. I didn't realize you could use it for anything.
You can use the server spec for just about anything too.
Okay.
Which is handy. But what I like about this, what I've been thinking about for a long time is that if I'm going to build an infrastructure from scratch using configuration management tools, then wouldn't I want to start from network topology and then go down into the server roles and what's happening there? And I don't know of, I think HashiCorp is probably the closest I've seen actually create, everybody says they have orchestration tools, but I don't know that they're actually saying from a network administrator's perspective, say, okay, I want these IP maps, I want these flash whatevers, I want my network to look like this, and then the developer can just say, inside of that network, I need these server roles, and here's the recipes for those, and say go, and really from the top down build a system, right? That seems to be something that's missing, and I don't think that the automation community, they kind of started with the developer. They kind of started with how do you want to set up these individual nodes, and I don't know that we've actually solved the problem for the network administrator. And that's why I'm interested in your point of view, because I think if we can create solutions that bridge those two together, bring them together, then we'll have a really nice way to organize the system.
So I agree. This is stuff you can see. This is me and another SE working together on we're basically trying to build a virtual environment. But we're using Vagrant, we're using Ansible, and we picked a certain tool set, and we're using Behave for our checkers.
Yeah.
But this is what I've been trying to build the last 2 weeks to do that rolling upgrade I was talking about earlier.
Right.
So this is all going to be automated for pretty much everything. So I mean, this is all Ansible, right? So just kind of taken away from and my coding sucks, but I've got a basic provision, build the network from scratch. Within this, and this initially is within Vagrant. So I just go into my console, my terminal window here, and say, okay, Vagrant up, and it builds this topology with all the links. And now I go and say, okay, go ahead and provision everything for layer 2, layer 3, however I want to provision it as a data center fabric. I've already got the automation playbooks there to do just that, so I'll pull it up. So my roles, here's a spine layer, here's a leaf layer, here's my servers. So I'm building out 2 layers of network with servers as well in one build. And we're kind of collaborating on the code just directly into Git. So I just, every time I do something on my laptop, I just push it back up, right? But then you take that and you say, okay, that's great, it's provisioned, now what do you do? Well, I want to go do some troubleshooting. So I'm going to go out and the entire network and say, okay, give me the status of my MLAG, my bridges, just whatever networking information I want to bring back, and it'll basically help it for me locally, so I can pull the entire network for information and dump it here to where I can see it all with one shot. So I don't have to have console windows open to 20 different boxes. Is that kind of hitting on where you're going?
Yeah.
So it's go ahead.
I was going to say, at this point, though, you got this in the server.
Absolutely.
So, connect your server, have your server go to their brain, or operating system, and their configuration. So, that can be orchestrated the whole way through. They'll got people who does that.
Sure.
With our servers. I'm sure they'll do.
Yeah, but isn't it kind of like, I think there's probably a few people that are doing it all from scratch. It's kind of like, hey, here's the networking environment, and yeah, there's a web server, puppet master, now provision your individual nodes, rather than have this holistic. So I feel like in DevOps we end up with a lot of rub because there's a natural disconnection between the network ops people or the network administrator who's trying to build this kind of permanent thing, and the DevOps people who are just trying to get access into that thing to provision their individual servers, rather than kind of what's cool about this is it's like the cohesive thought all the way from the top to the bottom.
I think the way to get where you're going is own the rack and build the rack, and then coordinate with the network group how you're going to connect that rack to the system.
Right.
And then you do exactly what you're saying.
Right.
You know, I'm down on that. Now, private space with all kinds of.
Right. Sure.
It has to be static though. Your network, I'm thinking more on demand, right? So if you're a hosting company and you're trying to, reduce operational costs, and if you've got a bunch of routers or and server stations, you really want them running if they're not being used. And as far as being able to shut them off, bring them back up whenever you want. I mean, you guys see cases like that where you're doing more of the on-demand, including the network. I know server stuff that on-demand spin up VMs and things like that. But is it applicable in this case with networking? I think so, but
Could be.
I think
But it doesn't have to.
I think DNS is probably where we run into the problem. Trying to make it completely throw it away, put it back together. DNS is probably my final limitation because I can't switch a domain to an IP instantly, right? I got to wait for that propagation. So if that were fixed, which it's not going to be, then I don't think there would be this idea that networking needs to be permanent and how the networking is allocated wouldn't be. But while that exists, there's some discontinuity of how destructive things can be.
I mean, containers is the other world is kind of pushing into networking being self-contained in the way your app interacts with the network,
Sure.
right? So I think there's other things that are around the corner which are going to give you a lot more freedom.
Sure.
I come from a testing environment. Doing what you're saying is what we're trying to do.
Right.
Absolutely. We stand up things we didn't test them, we move them, we don't. And we may do many alternatives and put our own secret sauce into the mix to do the testing.
Mm.
So that's kind of my opinion. That's all this. This is the part I need. And for me, I can't afford to do it. Everything has to be, you know, it's like rock solid. If anything moves, I gotta know it. You know, because it's a power system, and it's a big part of it.
Oh, yeah. we were down in Houston, somebody came up and was talking. Actually, we were at a meetup in Houston, and guy came up talking about there's like whole movements around just trying to protect and automate the power infrastructure.
Yes.
There's a lot of money from the government behind it too, yeah?
A lot of money we've made in this system.
Yep.
So I'm looking for, we didn't have access to the Linux switches, but I need them small.
Pardon?
That comes without saying, but yeah. But it's small and reliable. I think the days of just as Linux pretty much won the Unix wars. Yeah, I think it's got a chance in the other switch wars.
Sure looks that way.
Well, you're coming.
Yeah. Kind of big. Yep, absolutely. Good discussion. Yeah, alphabet soup. That's all I got for alphabet soup. I'm on for favorite number 2. First one did that one. This is the fan failure demo here. So, no questions? Okay, cool. All right, so reactive public manifest. This is actually a really cool demo. Like I said, we're going to simulate that fan failure. There's one device that we're going to pick on. It's Spine 2. This is a completely different network build. It's a lot bigger than the first network build. First one was pretty simple, right? 2 leaf, 2 spine, 2 servers. This is going to be like in devices, so a little bit bigger. So Spine 2, we're going to basically say, okay, we're going to change it up and we're going to use Puppet Enterprise as an add-on to what we've already shown, right? Just show this big Puppet. We're going to use Enterprise to actually move the device from a production environment and put him into a special environment just for basically cloud service. And when we put him in this different environment, we're going to have certain actions taken by Puppet to essentially route traffic around failed runs or pseudo failed runs, right? So, and that action we're going to take is we're going to set a certain amount of work. You switch code 1 to 6. We're just going to set the other process tasks. Basically, by doing that, you're telling them don't use these extra well. So, for those of you guys don't use this. All right. So that, what's that? It is expensive. All right. 10 switches, 4 leaves, and 4 leaf. So leaf, spine. Okay, a leaf. When you hear people talk about a leaf or top of rack, it's essentially the same thing. If you talk about spine, you're more talking about a second aggregation layer. It's aggregating a bunch of leaves. You probably never build a network like this because it's a gross waste of switching to the spine layer. Unless you're really to have like a one. So you don't want to have any of these switches. And then there's an edge layer as well. That's basically a way to reduce or external routing. And then 2 hosts. All right, so remember which device am I worried about here that we're going to pick on?
Spine 2.
Awesome. All right, so here's the manifest. Spine 2, you're going to have an IP address of 4.4.4.4. So something, we use something here called OSPF number. OSPF number means I put 2 IP addresses on the box. I put what we call a loopback, which I'm going to call 4.4.4.4. And I'm going to have a management Ethernet, which is out of band. That we usually want to talk about. So the loop back interface is basically going to be like the anchor point for all the collection traffic in the data plane. So all the interfaces are connecting. All these links don't have IP. So it just makes it really easy to build a two IPs per box. I don't have to worry about my automation. It's like, okay, it's just a lot. Okay, with that for now. So you'll see I'm putting ports 1.6 on the device in play. I'm using that loop back as the point, and then basically switch base role. And then basically saying, hey, use that loop back as my interface.
Is there an interface name then for the next hop based on like loop back plus interface name for outbound? Or how does it?
No. So with this, no, you're just basically saying, you're just telling it, hey, here's your loop back ID on that interface. You're not telling it how top it is. So like if this were, I use the BTP mode, I use the out. But in a BTP mode, all I tell it is, you've got a neighbor, and it's on this port, and he's either an internal neighbor or an external neighbor. I don't tell him what the next hop address is. I don't tell him to activate the facility. I just say, hey, you got a buddy out there that you have to visit. So back to this. I just keep reacting to the slide because all right, it's 10 switches. I got to jump out of that one of the ways. So line 2, we're at 4, and if I go look at the tree, see that all my items just kind of filled out at one, kind of reiterating the IPs on that box. All right, so now we're going to see that bag fan detection. I'm going to basically take down, essentially take those up. So I'm going to just kind of walk through some of the screenshots. The pump enterprise. You're going to see this again anyway. I'm actually rolling it down. So I'm going to take the new group name, spine 2 swap, and create that group. And once I've done so, I'm going to pin that node, spine 2 node with a spine 2 swap to take it out of production. So right here. And then there's what it looks like. So you can see the production environment. Here's my interface configuration. And then the only thing that's really changed is that then so this line on it was the cost. 5.
Well, it doesn't show what they were, they said you don't use it.
Exactly. I like the way you put that.
Yeah.
Sometimes language terms are the best term, right? You can see what's that? This guy?
Yeah.
So here, what's the deal? Here's the deal. Presentation one says never use recommended wide. So
I use Russian
fan, but it's not. That's where that comes from. What's on the president? All right. So, all right. This is me trying to be kind of gross. Spine, get it. Spine swap. All right. Swap their sword in the spine or just swap it.
All right. So
this is a little bit different environment than the last environment I showed you. We're actually using a Ravello for this demo because it scales better. The last demo was just self-contained. I can have access to it all the time. The Ravello demo, I've got to kind of schedule time on it and stuff like this. And it's sometimes unpredictable to get to remotely on Wi-Fi. You don't know. No. You're just pretty good. All right, so here's what Ravello looks like. Crapshoot. That's exactly what I'm looking for. So Ravello, you can see all the different nodes built out here. The servers down here. Basically, you start it up, talk about the address, and then the application environment. This is a shorter demo, so it's like a 5-minute total demo. So we're going to get that. I told you about my type. That's why 2 because I was really not that bad.
all right.
All right, so the workbench is really small on these. I can't make it much bigger. So I'm going into the legal one here. Look at the routes. You see I've got 1, 2, 3, 4, 5, all the way to 12. So I'm showing 12. You see it's got a next stop, and next 4.4.4.4.4. Maybe if you can't see it, take the word it's there. If not, we got it.
So on number, it seems the next loop back. And it has multiple lanes.
Yeah.
He now knows, hey, I can get to that.
Yeah, there's
Here's my cost.
because it's all multicast, right? So there's these discovery messages that go out, and then
A number wasn't talking about.
so unnumbered
Pretty new.
unnumbered is something you can do in a point-to-point world.
Yeah.
Where if I had I would do an unnumbered link across a point-to-point connection. So having these are all pretty much point-to-point links inside of a data center anyway. So unnumbered for OSPF to me isn't terribly interesting. It's cool. But BGP, you can't do unnumbered. I've never seen it done before I got here up to this company.
Yeah.
Because it's one of those things you got to have a TCP session established to bring the peering up, right? And so how do you do that with an IP interface? You don't just pass it through a port to a loopback. So something's got to make that connection happen. And so using IPv6 link local underneath to pass the V4 information between the two boxes. Now magically I've got a TCP connection path between the two devices to bring up the peer. So it's pretty cool. That's really cool. And to be able to do like a single IP address. So BGP is like, BGP is so hard to configure, right? It can be if you're doing like telco, edge, and doing a whole bunch of peering. It can be a nightmare to do some provisioning, but if you do it every day, you can really good at it. So if I'm managing a data center, I've got this unnumbered stuff available to me. I'm punching that ticket all day long. It's like that's just simplicity right there. Now my playbooks are 2 interfaces versus 54 plus 2. And I got to sit down and so imagine writing a playbook where I've got to say, okay, I need 54/30 IP addresses on this box. Now take that and say I've got 300 switches in a data center. That's a lot of IP addresses. One, to delve out, I've got customers constantly talking about I'm out of IPs. I got to do something different. And then you've got the other camp that's like, that's just a pain to configure. It is. And then writing the automation, do all the loops, all those size 30s, and wasting all those IPs. That number thing just makes a lot of sense.
Does it automatically calculate the cost of the 40 gigs of the lower cost?
Double check that, but yeah, that should be. Yeah, I don't make me swear to it right now, but I'll do it.
That's why my brain hurts a little bit with seeing it this way.
Yeah.
Cisco as well, so
Yeah.
it's awesome.
Yes, it is.
All right.
All right.
We got a next talk?
Okay, I'll just kind of keep bringing up the slide just to show you who 4 is. All right, so now I'm going to go into enterprise. I'm going to go to basically hit that node now. And by the way, I think I put this on YouTube when I actually have video too. Just how public it is. He's got that.
If not, this is on YouTube right now,
Oh, there you go.
like live.
Spine 2, pin it, commit it. No. All right, so our work in enterprise is almost complete. So now, look, the route's still there. So what about this one? So by default, public runs how many times? How often? 20 minutes. Yeah. So I didn't wait for 20 minutes. I gave it a kick in the tail right here. So dash T for kick in the tail. All right. Looky there. Got my plus. Somebody's really good with that cool video. Just kidding.
So
Over here, the route show again. Go for that. So basically, yeah, it worked, right?
pretty much toss it out.
Going nuts with the, I use the red one. All right, so we're essentially at this stage now, right? So I'm going to go back. Go ahead and pin down.
Time served.
Basically, the rest of the video is just back on the question. It's going and proving out the whole thing is going to work. Kicking the tail again. I know that's more. I think that'll show you that. I like it. That's a nice little notification. Environment, my cost. Get rid of that line.
There's my route back.
So we're back to normal. So just a real simple exercise, and
Use more of the cost, right?
yeah, just took that cost back to reality the way. That's it. Yeah, okay, so I went back into the group and all that stuff, so we'll let him do his thing. So here's, if you guys actually want to run this stuff, there's the link. I can provide the link too, or provide the slides or whatever we want to do here. But you can pull the code down and run it yourself. If you have insomnia or something like that. So a few of the modules that we need to use for the lab. And then just some stuff about the community. So I don't know if this is out of bounds or not, but our community guys like, if you're doing meetups, talk about the community. So, and there's, if you want to do, like, one of the things that I do a lot is we can talk about virtual tools, like on the box with favorite and box. Man, I use those every day. It's like, okay, spin up this network, test out this functionality. Like, I had a guy earlier this week. It's like, I can't get what was it, Datadog. He goes, I can't get the Datadog install right. It's like, all right, cool. We'll kick this off and try to get it to work right. Just kind of play around with it and do it. It's amazing because I come from a world where you go out, you procure a box, you try to get it set up with power, and then you do connectivity, and then you just, how many racks did I had 10 racks in that rack, right? It took me freaking years to get that thing running. And it's like, you build it, and then you're afraid to touch it because you don't want it to break. So, now it's all broken. So, great. All those years. My legacy's gone. That's too bad. So now you take these things, you build these virtual machines and spin this stuff up like that. And it's like, okay, now I can just completely recreate a network in minutes. And then just repetitively create it without even having to think. It's just say, go do this. And it's just a beautiful thing.
So your community link there, do you have like groups of people posts that out there?
Yep.
That they can access?
Absolutely. So between here and GitHub, so if you want to like play with more automation, that GitHub link I was showing you guys, right? Sometimes when you share your screen, it doesn't, on the Mac, it doesn't want to change window. There we go. All right, so here's this one demo I was showing you guys, but I'm going to go to my repo. So I'm trying to build a whole repository of my own playbooks. And just some basic stuff that I would use day to day. Like, I want to set up NTP. Okay, how do I do that? Here's the playbook to do it. I'm just creating them and dumping them out here as I go. And you see, obviously, some stuff still needs work. And then, you know, use at your own risk. So anyway, the stuff is out there. We got a ton of stuff on. Like, my company's got about 40 or 50 different repos of just, you know, automation examples and stuff like that. Yeah. Any questions? Enlightening? Boring? Feedback? Okay, good. Is there any kind of feedback on other talks on this kind of stuff that would be better to see than just basic demos like this? No?
I mean, it'd be a way more exotic, but maybe having interaction with, say, OpenStack and.
Oh, I've got that. This just wasn't an OpenStack meetup. Oh, yeah. If you guys are interested, it's up to you guys, because you guys kind of run the meetup, right? If there's interest in this group with interacting with OpenStack, I can talk to that too. It's not necessarily just me, but that's something that we use the same kind of tool sets to do OpenStack over the top.
And my engineers will be sure coming from Idaho, so I'll hook him up with you to make it help you on that too.
Okay.